All right, to part one here, and if you've been following along through our class, we kind of jumping around this unit through different modules. But today we're going to focus on graphing linear equations and inequalities. Now, part one, we're just going to focus on the graphing linear equations, and so this will be mostly review for us. There's going to be three methods we go over. The first method is to make a table. Then the book jumps in to write saying that once you make a table to choose values of 0. And I want to stop you right there and say that I want to call it step 0. All right. My step 0 would be to solve for y. Right? And if you're really good at graphing, you are asking them, why are we making a table? All right, and I understand it completely, and so we're not going to assign very many of these, but if you're one of the students who struggles with graphing, then this is always a good kind of review of where it comes from and how inputs and outputs are derived. And we want to graph this particular linear function for this problem, and it's nice because it's already solved for y, but we're going to have an example coming up where that's not the case, and so I wanted to make a note that that is my step 0. And then you have to pick values of x. And on the homework, you can pick your own values of x here. Just be careful. If you pick a number too large or too small, it'll make it hard and difficult to graph. All right. Also, you only on my assignments have to pick 3 points. So you can choose carefully any 3 you see fit. Now, once you have tried those points or picked those points in your table, you go ahead and complete the table, which means that you put -1 in for x. So 2x is now -1. 2 times -1 is -2. -1 is -3. 2 times 0 is 0. -1 is -1. 2 times 1 is 2. -1 is +1. 2 times 2 is 4. -1 is 3. And so each of those is a coordinate now. -1, -3, 0, -1, 1, 1, and 2, 3. And so once you have made a table, you need to graph the points. And so you graph those coordinates, -1, -3, 0, 1, 1, 1, 2, 3. And then you connect the dots. And now that's the graph. That's the whole of it. That's the longest way we're going to do these problems, but it is good practice. And we are going to have some, so make sure you know how to make a table. Method 2. Method 2 is using the intercepts. And I put notes here on this page of how to use intercepts, but I also want to make a note here that I will use this most of the time when my equation is in standard form. So that is the when I will use this. And so to find the x-intercept, you plug 0 in for y and solve. And we'll talk about something called the cover-up method as well. It's just a quicker way of plugging 0 in for y. All right? To find the y-intercept, you plug 0 in for x and solve. And so like when we go back to tables, we talked about finding intercepts using a table before. The zeros are the keys. All right, and so you plug 0 in for y, you only have an x number, so it's the x-intercept, and vice versa here for the y-intercept. And so the first thing I want to note here is that this is the equation they are asking us to graph. And notice it's in standard form. And so I would call it the cover-up method, which means to find the x-intercept, I simply cover up the y. I pretend like it's not there. Right? And so if I just cover up the y, I'm only looking at this 2x equals 6, which is the step right here. 2x equals 6, divide 2 on both sides, get x equals 3, and then make sure you graph it. So cover up the y, solve it, plot your point, plot your intercept. X-intercept is 3. Do the same kind of thing here for the y-intercept. Just kind of cover up your x. If you just kind of cover up your x, you just have 3y equals 6. Divide both sides by 3. You get y equals 2. You can graph that intercept now. And then you just connect the dots. And then review from what we've talked about in class. You need to know that y equals mx plus b. This up here is called slope-intercept form, y equals mx plus b. The slope is the rise over the run. And then the y-intercept is on the y-axis. And especially if you're bad at graphing, it's nice to think about that as my start point. So I want to start at some point on the y-axis. And so let's graph this equation right here, y equals 1/3 x plus 1. Well, the plus 1 is the b, so the y-intercept is 1. And so notice that's where they started the graph. Then the slope is 1/3, rise over run, so up 1 over 3. I don't care that the coordinates are 3, 2. I care that we went up 1 over 3. Now it was positive, so we went up 1 and right 3. If it had been negative, we either would have went down 1 and right 3, or up 1 and back 3. Which means here for this, I could also go for positive. I could also, instead of going up and right, I could go down and left. Now, once I have the 2 points, I play connect the dots. All right, let's look at examples. To make a table here, the first thing I need to do, again, would be to solve it for y. And so I'm going to add 7 to both sides of this equal sign. I get x minus 2y equals 7. I'm going to minus the x over. And then that gives me negative 2y equals, it would be okay to put 7 minus x. I get just so used to writing things in slope-intercept form, I would write the x first, so it's negative x and then positive 7. Then I divide both sides by negative 2. And just because we're going to make a table for this one, all right, and since I'm making a table, I'm going to go ahead and use decimals. And so I'm going to say negative divided by negative is positive 0.5x. And positive 7 divided by negative 2 is negative 3.5. If I was actually going to graph using slope-intercept form, I probably would leave it as fractions. But because I'm making a table, I went ahead and used the decimals. And so now we need to make a table. And again, we need to remember that y equals 0.5x minus 3.5. And so I plug in the negative 3. Half of negative 3 is negative 1.5, minus 3.5 is negative 5. And then I plug in the negative 1. Negative 1 times 0.5 is negative 0.5, minus 3.5 is negative 4. And then I plug in positive 1. 0.5 times 1 is just 0.5, minus 3.5 is just negative 3. Then I plug in positive 3. 3 times 0.5 is 1.5, minus 3.5 is negative 2. And then the last one they ask you to plug in for this one is 5. Half of 5 is 2.5, minus 3.5 is negative 1. And so that's the first thing you have to do, is to make your table. You have your x's, and now you have your y's. After I make my table, I need to graph the points. And so I would graph negative 3, negative 5. And I graph negative 1, negative 4. And I graph positive 1, negative 3. And 3, negative 2. And 5, negative 1. And then I go ahead and I play connect the dots. Intercepts. So cover up method. Cover up the y. 3x equals negative 12. Cover up the x. Negative 2y equals negative 12. Solve each one. Divide both sides by 3. I get x equals negative 4. Divide both sides by negative 2. I get y equals 6. Again, to find the x-intercept, I just cover up the y. To find the y-intercept, I just cover up the x. And then I use those intercepts of negative 4. And so I had x equal negative 4. I had y equal, what was it, 6? Yep, y equaled 6. And so I graph those points. Negative 4 on the x is right here. 6 on the y is right there. I play connect the dots, and I'm done. Now I need to identify what is my m, what is my b. And so my m, my slope is 3 over 2. My b is negative 4. And so remember, that's my starting point. So I start down here at negative 4. And then I go up 3, up 1, 2, 3, over 2, 1, 2. And so that now is my new point. And once I have my points, I play connect the dots. Go ahead and give these a try. Best of luck to you.